To test for integration, we estimate the regression model first, then store the residual into a new variable called E hat. Then we perform the DF test on it. So that's the first step, is to estimate the regression model. B is the dependent variable, F is the independent variable. Note that both of them are not stationary. But now we are focusing on, we focus on the residual of this regression model. Now we have put that into a new variable called E hat already. Then the next step is to perform a DF test. So we're performing test on E hat. We don't need a constant because by construction, residual has a zero mean. And we would like to include one lag term, and this is an augmented DF test just to take into account the autocorrelation issue. So if we submit this line, we may notice that, oh, the test statistics are pretty small. It's minus 4.196 is in the reduction region. So we can conclude the residual series is stationary. Then the two variables B and F are co-integrated. Then the next step is to estimate this error correction model. So the first thing we need to do is to generate a variable that is the difference of B. Let me explain why we need to generate this variable first. If we go back to our PowerPoint, what we are trying to estimate is an error correction model based on the expression on the slide. So essentially, we have this delta YT as the dependent variable. Right-hand side, we have alpha, beta 1, beta 2, delta null. And if we have other lagged terms of the first difference of xt, we will have other coefficient as well. However, what we have here is not a linear regression model because you have alpha times beta 1 here and also alpha times beta 2 in front of xt minus 1. It's not a linear model. So we need to use this NL command to estimate a nonlinear model. But NL does not allow this time series operator in the left-hand side of the equation. So we need to generate a variable to avoid using this d dot in that expression later. What we need to do is to write out this equation in an NL command. Then we let the system to estimate the model using nonlinear regression technique. So let's go back to stata. Now we generate this db already. So this is a variable. We don't need to use d dot b in the next command line. So the next command line is here. So it's nonlinear regression. db is used as the dependent variable. What I was trying to say is if we use d dot here, it's not going to be allowed. So d dot is an operator. We have to use db, a variable that's created in the previous step. Then this is the equation that is corresponding to the PowerPoint in the equation that we just saw on the PowerPoint slide. So I write it out. So alpha, beta 1, beta 2, delta null, and we also have delta 1 because we have the lag term of df in this equation. Then if we submit this command line, we will be able to estimate this regression model. And those are the alpha, beta, and delta estimated by using this nonlinear regression model. And you can compare them with the numbers that we obtained on my PowerPoint slide. They are quite close to each other. So if you want to check whether the co-integration condition is met, you can also generate the E hat from this regression. So this is the way to calculate the E hat. So what we are doing right now is, let's go back to the PowerPoint. So we estimate this model already. And we also have this expression. I showed to you, okay, that is the part within this bracket. That's the error part of this error correction model. That is essentially the residual from this regression analysis. And you can also estimate the value of this residual and check whether this particular part, is stationary or not. We checked both. The first difference of F and B are stationary. How about this part? If it is stationary, then the whole model, everything there is stationary. The way to check it is to, if we go back to stata, we drop E hat first because we don't want to mess up. E hat is the old residual series that we used before. We drop it, then we create a new one, and that is entirely based on the coefficient estimate from this regression model. So for example, beta 1 constant, that's the value of beta 1 is 1.429. This is a status way of retrieving coefficient estimate from this nonlinear regression procedure. Then we perform a DF test that's on E hat or the series that we have just generated, like one no constant. That will give us, okay, we generate the series and perform the DF test, and obviously we reject null hypothesis, which once again confirmed this is a valid linear regression analysis. All the variables in this regression all of them are stationary.